Hello students, once again welcome you to GK's maths classes. Today we are going to do a topic on relations and functions. Already we have discussed the introduction to relations, introduction to functions, and we have also solved a reasonable number of problems. Today mostly we will wind up with this chapter by doing few more questions, and if time permits we will also talk about the number of reflexive relation, number of symmetric relation, number of transitive relation, and also we'll try to see the number of equivalence relation. And if time permits, we'll once again try to do the number of one-to-one, on-to, and bijective. Okay, if it takes a lot of time, then we will do it in the next video. Okay, so I hope we'll get inside the last part of problems in functions. Okay, let's start. Once again, as an introduction, what we do is, what is a one-to-one function? One-to-one function, otherwise called injective. So what do you know? F is a function from A to B. This is said to be one-to-one when for every x1 comma x2 belongs to A, if f of x1 equal to f of x2, then I can say x1, then I should get x1 equal to x2. If x1 and x2 are same, f of x1 and f of x2 must be same. Or you can have f of x1 not equal to f of x2. If the images are different, then the pre-images should also be different. Okay, so this is the definition of one-to-one. Already we have discussed it. I will also put the link of those videos in this video, so for your reference. Okay, but I'm just to begin with, I'm just giving you a small introduction. Detail we have done before. Okay, now what is an onto function? Onto function is also called surjective. So I will say f from A to B is onto. When do I say that? I will say this if the codomain and range are equal, or in other words, if every element in the codomain have a pre-image, or you can say no element in the codomain is left out, every element should be mapped. Okay, let's go to the question. First question. This is a very, very, very important question, so we'll try to do this problem. F is a function from R to R defined by f of x is equal to x by, it is small letter x by x square plus 1. Check if f is one-to-one and onto. Now how do I check one-to-one? For every x1 comma x2 belongs to R, if f of x1 equal to f of x2. Now what is f of x1? F of x1 is nothing but x1 by x1 square plus 1, and f of x2 will be x2 by x2 square plus 1. Now we cross multiply. When you cross multiply, what do I get? I'll get x1 x2 square plus x1 is equal to x1 square x2 plus x2. Usual stuff, right? Now you bring everything to one side, you get x1 x2 square plus x1 minus x1 square x2 minus x2 equal to 0. Now look at these two. What is common in them? Here x1 x2 is common, so what do I get? I get x2. In fact, I'll take minus outside so that I'll get x1 minus x2, and I can write this as x1 minus x2 equal to 0. Now what is common? Now clearly x1 minus x2 is common, so I'll left with 1 minus x1 x2 equal to 0. So what is the option? So x1 can be equal to x2, or there's another horrible thing. What is that? You can have x1 x2 equal to 1. Okay. So in the exam when they ask this question, don't do all this. I have done these things for you to understand, okay, that it's also possible to get x1, x2 is 1. So here in the exam, if you know, if this question comes in the exam, what you should do is very simple. You just have to take two numbers which are reciprocal to each other, so that when you multiply, you get 1, right? So what is f of 2? F of 2 will be 2 by 2 square plus 1, which is 2 by 5. What is f of 1 by 2? Which is 1 by 2 by 1 by 4 plus 1. So if you simplify, once again you get 2 by 5. So clearly f of 2 equal to f of 1 by 2. See, 2 not equal to 1 by 2, I got f of 2 equal to f of 1 by 2. This implies f is not 1 to 1. So how do I come up with this example? I came up with this example because because when I did this, I had a situation where x1 equal to x2. Also I have x1, x2 is 1. Since I know x1, x2 is 1 also works for this. So that means I have to select two numbers whose product is 1. So I selected two numbers whose product is 1 and they are different obviously. So f of 2 and f of 1 by 2 is the same. So that shows distinct images, that is 2 and 1 by 2 go to 2 by 5. So this is not 1 to 1. Okay, the diagrammatically also you can show. So this I don't want. So now we have proved that f is 1 to 1. In the exam, again I am repeating, this is more than enough. You don't have to show this step. Now for onto. Now what is onto? Onto is I want to find x in terms of y. So what is y equal to? X by x square plus 1. And when I cross multiply, what do I get? I get x square y plus y equal to x. I am getting a quadratic in x, that is x square y minus x plus y equal to 0. Clear? Now, how do you solve the quadratic? So x is equal to minus b. What is minus b? Minus b is 1 minus b plus or minus square root of b square. What is b square? 1 minus 4 ac. A is y, c is y. So ac is y square divided by 2y. Divided by 2a. Correct? Clearly, you know, this square root is possible only when 1 minus 4y square is positive. Only when 1 minus 4y square is positive. But you already know this result that if it is a square minus x square, definitely your x should lie between plus a and minus a. Correct? If it is a square minus x square, your x should lie between plus a and minus a. So here, using the same idea, what do I get? You can write this as 1 by 4 minus y square is greater than or equal to 0. See, it's the same logic. So y will lie between plus of and minus of. But here there's a problem. Y cannot be 0. You see, y cannot be 0. So in this case, y belongs to minus half to plus half. It looks like you are excluding 0. If you take this situation, you get x is excluding 0. But you cannot exclude 0 because when x is 0, you have y is 0. When you put x is 0, y is 0. So my range is minus 1 by 2 comma plus 1 by 2, which is not equal to codomain. Therefore, f is not onto. It is neither 1 to 1 nor onto. This is a board question. Again, I'll repeat, I got a quadratic in x. When I get a quadratic in x, you know the square root is possible, only the number inside is positive. So 1 minus 4y square should be positive. which can be written as 1 by 4 minus y square is greater than or equal to 0. So using this result, here my a, here my a is 1 by 2. Okay? If it is root of a square minus x square, your x should lie between minus a and plus a. So similarly here y should lie between plus half and minus half. I have to exclude 0 because otherwise this will not be well defined, right? So I exclude 0, but you cannot exclude 0 because when x is 0, y is, so you have to redefine the function suitably, okay? So x is 0, y is 0. That shows that you have to include 0. So the range is minus half to plus half. So when you find inverse, okay, people will write it as, say for example, this is not required for you. When you write inverse, you will write 1 plus or minus root of 1 minus 4y square by 2y, y not equal to 0, and 0 when y is 0. Okay. Just to redefine the function. Okay. But this is not required for you. Okay. So that finishes this problem. This is a board question. As I told you, if you do only this, it's enough. This is not required. This is only for your understanding and doing it. Okay. This is an NCERT question. The previous problem is not an NCERT question, it's a board question. Okay. Now consider f from r plus to 4 comma infinity given by f of x. So what is my function? My function is from r plus positive real numbers to closed interval 4 to infinity. And how it is defined as? It is defined as x square plus 4. Show that f is invertible. Invertible, this is all not there for us, okay? So all that I need to do is check whether f is 1 to 1 and on to. Change the question to 1 to 1 and on to. This is in the NCERT, old NCERT, they have talked about inverse. We don't have inverse in the syllabus. So if you want to have an inverse, which we discussed already, the function should be 1 to 1 and on to. So you can modify this question as check whether the function is 1 to 1 and on to. Simple. Okay. Let's see. 1 to 1 function. For every x1 comma x2 belongs to R plus, what do you know? If f of x1 equal to f of x2. Now what is f of x1? F of x1 is x1 square plus 4. And what is f of x2? x2 square plus 4. So 4 can be cancelled. You get x1 square equal to x2 square. Obviously, since it is r plus, I don't have to take plus or minus. Okay. Since it is r plus, x1 and x2 are positive. Okay. Since x1 and x2 are both positive, I don't have to take it. This implies the function is 1 to 1. So you have proved the given function is 1 to 1. Now how do I check for on to? On to is very simple. You have y equal to x square plus 4. Like the previous problem, my job is to find x in terms of y. So what is x square equal to? Y minus 4. And since x belongs to r plus, definitely x is greater than or equal to 0. Okay. So when x is greater than or equal to 0, x square will also be greater than or equal to 0, correct? So when x, or if you want, you can write x is equal to root of y minus 4. I am not writing plus or minus because x is positive. So and a positive number will be equal to a positive number. This is possible only when y minus 4 is greater than or equal to 0. Otherwise square root is not defined. Therefore y is greater than or equal to 4. What do you mean by greater than or equal to 4? All numbers from 4 to infinity. So y belongs to closed interval 4, open interval infinity, because infinity is not a real number. So this is nothing but your range, and it happens to be your codomain. See, your codomain is also that. Since the range equal to codomain, you can conclude that the function is onto. Since the function is 1 to 1 and onto, it's bijective. If it is bijective, definitely inverse will exist. Those things are not there for us, so don't bother. Check whether it is 1 to 1 and onto. Since it is 1 to 1 and onto, you can say f is bijective. Is it clear? Okay, let's go to the next question. This is again an NCERT, I think it's a word dot example question. You have a function f from natural numbers to natural numbers. How it is defined as? It is given that f of 1 is 1 and f of 2 is also 1, and it's also given that f of x is x minus 1 when x is greater than 2. I have to check whether it is 1 to 1 or not. It's clearly given it is not 1 to 1. It's very obvious because 1 not equal to 2, 1 and 2 are not equal. But f of 1 is equal to f of 2. Both are equal to 1. This implies f is not 1 to 1. Therefore, f is not 1 to 1. Now I have to find onto. Now how do I find onto? Let us see. First let me represent it diagrammatically. All my natural numbers are like 1, 2, 3, 4, 5, 6, so on to infinity. And here also it's natural numbers. It is 1, 2, 3, 4, 5, 6, 7 and so on to infinity. Yes, very clearly said f of 1 is 1. So 1 goes to 1 and 2 also goes to 1, right? 2 also goes to 1. Now what is f of 3? F of 3 will be, it's 3 minus 1. 3 minus 1 is 2. So 3 will go to 2. 3 goes to 2. And what is f of 4? F of 4 is 4 minus 1, which is 3. So 4 goes to 3. Correct? So clearly you can see my codomain is natural numbers. Natural numbers. My range is also natural numbers. Can you see that? X minus 1, okay, f of x will be, f of x will belong to, what I can say, f of x will belong to 2 comma infinity, okay, and f of 1 is 1 and f of 2 is also 1. So my range will be natural numbers. I'm talking about natural numbers, okay? This is natural numbers 2 to infinity. So range equal to codomain. Range equal to codomain. Therefore, what do you say about the function? Therefore, f is onto. So this is what he wants me to prove. I have to show that f is onto, but f is not 1 to 1. Why it is not 1 to 1? I think it's very obvious. One of the most important question in your NCERT book, okay? Here I'll change the question, show that it is invertible. Instead you say check whether it is 1 to 1 and onto. And very, very, very important question, okay? Either it will come in your school exam or it will come in your board exam. It has come many times, it's very, very important. So let us go to this. Now here, once again, f is a function from r to minus 5 comma infinity, defined as f of x is equal to 9x square plus 6x minus 5. R plus, so it is 0 to infinity. So here R plus means all positive real numbers including 0. That is how it is defined as, okay? I have not taken that part. R plus means all positive real numbers including 0, because that will be mentioned in the question, okay? Because all positive real numbers means you should not include 0, because 0 is neither positive nor negative. But here I have taken the convention as R plus is all positive real numbers including 0. Okay? Now 1 to 1. How do I verify 1 to 1? For every x1 comma x2 belongs to R plus, that is 0 to infinity, if f of x1 equal to f of x2. What is f of x1? F of x1 is 9x1 square plus 6x1 minus 5 equal to 9x2 square plus 6x2 minus 5. 5 and 5 cancels. Bring all the term to one side. So what do you get? 9x1 square minus 9x2 square plus 6x1 minus 6x2 equal to 0. So 9 is common. So I get x1 plus x2 into x1 minus x2. I am using a square minus b square formula. Plus 6 is common. I get x1 minus x2. Now clearly you see x1 minus x2 is common. So I get 9x1 plus 9x2 plus 6 equal to 0. Like the question that we did before, okay, like the question we did here x1, when you have a product as 0, I wrote x1 equal to x2, but either this can be 0 or this also can be 0. We don't know. So that is why I have to consider this case. Whereas in this problem, it's very, very clear because only it's possible that x1 minus x2 will be 0. 9x1 plus 9x2 plus 6 can never be 0 because x1 and x2 belongs to natural numbers. Sorry, x1 and x2 belongs to R plus. They are positive real numbers. Since they are positive, even if they are 0, you get 6. 6 is 0 plus 0 plus 6 cannot be 0. Therefore, this cannot be 0, so only this is a possibility. This implies x1 equal to x2. This shows f is 1 to 1. I hope you see the difference between this problem and this one. Here I have to consider, because I don't know that this is not 0. Since I don't know, I have to take that also, take the possibility that it can also be 0. So x1 minus x2 is 0, or 1 minus x1 x2 is also 0. That is why we got this situation. Whereas in this problem, it's very clear that 9x1 plus 9x2 plus 6 can never be 0 because they all belong to positive real numbers. So x1 equal to x2, which implies the function is 1 to 1. Now how do I check onto? There are different ways to do. You can complete the square and do it, or I prefer to use the quadratic formula. I always like to use the quadratic formula because that will be a common thing for any problem. In this case, the easiest thing is to complete the square because it's a perfect square. 9x square is like 3x the whole square. What if it is 3x square? Then you have to write it as root 3x whole square. It gets complicated. So let us have a common method to do these problems so that any situation comes, you will be able to handle it. So this is 9x square plus 6x minus of 5 plus y equal to 0. I brought this y that side. Okay. So it's a quadratic equation, quadratic in x. So what is x is equal to? Minus b plus or minus root of b square minus 4 ac. Minus of minus is plus 5 plus y divided by 9. Divided by 2a, no? So it's 2a. Minus b plus or minus root of b square minus 4ac by 2a. Now clearly 36 is common. So you get minus 6 plus square root plus 6 into square root of 1 plus 5 plus y. Now if you notice, I did not write plus or minus, I wrote only plus. Why? Because my x belongs to R plus. If I take minus sign also, minus 6 minus will be a negative number and x will become negative, but x cannot be negative because x belongs to real number. I repeat again, if it was minus, if I take in minus, then this entire number is a negative number, which is nothing but x. So that means you are saying that x is negative, but x cannot be negative because x belongs to positive real numbers. So that is why I ignore the minus sign. I take only the plus sign, and I've given a reason. The reason is x is always, x belongs to R plus. Okay. So now what do you do? This is minus 1 plus root of 6 plus y, my b square minus 4ac minus 5 minus y, okay, b square minus 4ac. Is it my calculation right? Okay, minus 4ac divided by 3. Correct? Now clearly x is greater than or equal to 0. When I say x is greater than or equal to 0, I can say minus 1 plus root of y plus 6 divided by 3 is greater than or equal to 0 because x is nothing but this. Now if you cross multiply, since it is a positive quantity, it doesn't really affect you. Is greater than or equal to 0. So what is root of y plus 6? Is greater than or equal to 1. So what do you say about y plus 6? Is greater than or equal to 1 by squaring both sides. Therefore y is greater than or equal to minus 5. This implies my y belongs to minus 5 to infinity, because from minus 5 so on, okay, minus 5 to infinity. This is your range. Now what is the codomain? Codomain is also minus 5 to infinity. So what have we proved? Range equal to codomain. This implies the function is onto. Very, very important type of question. Okay? Very, very important. But if you don't want to do all this, you can also by completing this. I'll just mention it there, so that in case someone wants to do it in a very shorter way, you can do it. So can I say this is 3x the whole square minus 2 into 3x into 1, right? I'm writing 6x as 2 into 3x, right? Plus 1 square minus 1 square minus 5. So automatically this becomes 3x plus 1 the whole square minus 6. Now bring the minus 6 this side, you get y plus 6 is equal to 3x plus 1 the whole square. Taking square root, you get 3x plus 1 equal to root of y plus 6. I am taking only positive square root because 3x plus 1 is always positive, because x is from set of all positive real numbers. So clearly from this you get x is equal to minus 1 plus root of y plus 6 divided by 3, which is exactly this. So this is shorter. But I advise this method because what if we don't get a perfect square like this? You don't get 3x whole square. Suppose if it is 2x square, then you have to think. So to avoid all that, just do mechanically, you get the answer. It's not difficult. Any method you adopt. Now next, go to the next question. It is a question from NCERT exemplar. Okay, this is a question from NCERT exemplar. It's a very nice problem. F is a function from 2 to infinity. From where to where? From closed interval 2 to open interval infinity. And how it is unto what? Two real numbers. How it is defined as? It is defined as x square minus 4x plus 5. It is defined as x square minus 4x plus 5. I have to check whether it is 1 to 1 and onto, which is our job to find 1 to 1 and onto. So what do you do? For every x1 comma x2, same procedure for all problems. 2 to infinity. If f of x1 equal to f of x2, this implies what? X square minus 4x1 plus 5 equal to, this will be x2 square minus 4x2 plus 5. 5 and 5 cancels. I get x1 square minus x2 square minus 4x1 plus 4x2 equal to 0. Now what is this? This is a plus b into a minus b. Usual stuff. Minus 4 is common. I get x1 minus x2. Now what is common in this? x1 minus x2 into x1 plus x2 minus 4 equal to 0. Correct? Now your x1 and x2 belongs to what? They belong to closed interval 2 comma infinity. Okay, let us assume x1 is 2 and say x2 is 2.1. If you substitute, what will happen? 2 plus 2.1 minus 2 will never be 0, because they are all positive. So x1 and x2 will definitely be greater than 4. Will definitely be greater than 4. Okay, so even this shows, okay, this shows x1 must be equal to x2, correct? So x1 plus x2 minus 4 cannot be 0. If you choose any two numbers, suppose you choose x1 as 2 and x2 also 2, this situation comes. x1 equal to x2, obviously it works. So you should have, if you take x1 and x2, they are not same. Definitely, since x1 and x2 belongs to 2 comma infinity, x1 plus x2 will be definitely greater than 4. Since it is greater than 4, 4 minus 4, a number greater than 4 minus 4 will always be not 0. Let's not bother about the sign, it will not be 0. So this cannot be 0. So the only possibility is x1 equal to x2. This shows that f is 1 to 1. Here slightly confusing. Watch this carefully. Again I'll repeat. x1 and x2 belongs to 2 comma infinity. The numbers are from 2 to infinity. So what happens is, if I choose a number 2 and the next number, I say even a small number like 2.1, x1 plus x2 will be definitely greater than 4. So a number greater than 4 minus 4 will never be 0. So this is not possible. You cannot have x1 plus x2 minus 4 equal to 0. Okay, that's what I was trying to say. Now how do I check it's onto? Okay, so onto. Previous problem I did by quadratic formula. Here just to show you the variety, I will do by completing this square. Because this looks very nice, a square minus 2ab, right? I am writing 4x as 2ab. This is my a square minus 2ab plus b square. Okay, so I am adding 4, but actually it is 5. So plus 1, or okay, that's better, that's easy. X square plus 2ab plus b square I need. B square is 4. But since I have plus 5, I can write 5 as 4 plus 1. So which is effectively what? X minus 2 the whole square plus 1. X minus 2 the whole square plus 1. Now clearly from this, x minus 2 the whole square will be y minus 1. So what is x minus 2? Will be square root of y minus 1. Now why it is y minus 1? Because, why I am not taking plus or minus? Because x is greater than or equal to 2. X is greater than or equal, because x belongs to 2 comma infinity. X will always be greater than or equal to 2. That means x minus 2 will be greater than or equal to 0. So since it is a positive number, I don't have to write plus or minus. Now clearly this is, since x minus 2 is greater than or equal to 0, root of y minus 1 will be greater than or equal to 0. Therefore y will be greater than or equal to 1. So my range will be 1 to infinity, which is not equal to codomain. This implies f is not onto. So I have proved the function is 1 to 1, but it is not onto, and he has also asked me to find range of f. So my range of f is 1 to infinity. Suppose if I redefine the function from 2 to infinity to closed interval 1 to infinity, this will be 1 to 1 and onto. Suppose if I redefine. Okay. If I otherwise for 2 to infinity to r, it is 1 to 1, but it cannot be onto. Okay, this is a very, very simple question. It's a 1 mark question, very, very important. It's an NCERT worked out example. Now here I have two sets A and B. It is having 1, 2, 3. The other set is also having 1, 2, 3. Here said the function is onto. Here said the function is onto. Here, since he has said the function is onto, what will happen? Codomain equal to range. Why? F is onto. Since f is onto, my codomain should be equal to range. That means every element here should be used, correct? And since both of them have same number of element, okay, for that to be possible, the function has to be 1 to 1. For example, look at this. Suppose 2 go to 3, 3 go to 2, definitely 2 have to go to 1. Definitely 2 have to go to 1. If 2 does not go to 1, it cannot be on 2. Okay, so 2 have to go to 1. Therefore, you can say the function is 1 to 1. There's nothing in it. If the two elements are, if the two sets are same, and if the function is on to, you can make it as a result also. If f is a function from a to b, if the number of element in a equal to number of element in b, and if f is on to, definitely f will be 1 to 1. Definitely f will be 1 to 1. Okay? Because if it is not 1 to 1, that means some element will be left out. Okay? For example, if it is not on to, let us say it's not on to, that means some element will be left out here. If some element is going to be left out here, see this? If I don't have this 3 used, then it cannot be on to. So if it is on to, this 3 must be used. If 3 has to be used, and if it is going to be a function, then every element here should be mapped to this by a 1 to 1 function only. There is no other choice. See? For instance, let me take one more diagram. 1, 2, 3, 1, 2, 3, 4. For example, if I have 4 elements, see? Or I can say, look at this. This is 1 to 1, but it is not on to. 2 is left out. Okay? Suppose let us assume 2 is not there at all. The number of elements are same. Number of elements are same. It is on to means it has to be 1 to 1. You understand? So that's the idea. And it's a reverse of this problem. There's nothing in it. Very, very important. A to B, 1, 2, 3, 1, 2, 3. It is 1 to 1. It is 1 to 1 means there must be a perfect match. Right? Every element should be used. Therefore, F is on to. Correct? If it is 1 to 1, let's come back to this. Okay. Now the next question. You can see this is set A, 1, 2, 3. This is set B, which is also 1, 2, 3. Clearly, F is 1 to 1. It's given 1 to 1. So this is 1 to 1. Since the both of same number of element, F must be on to. F must be on to. If it is not on to, okay, that means some element must be left out. Okay, that means 3 must have mapped to this. Okay. If 3 is mapped to this, it is not 1 to 1. But what about 3? 3 is not mapped. Okay. So if they have same number, see, if this is 1, 2, 3, this is 1, 2, 3. If 3 is not mapped, if it is not on 2, okay, let us assume that it is not on 2, it cannot be 1 to 1 also. So this is the only way possible. 1, 2, 3, 1, 2, 3, 3, 2, 1. F is 1 to 1, F is on to. So you can use this result. If F is on to or 1 to 1, then F will be 1 to 1 or 1 to. Okay? Okay, then we'll continue again in the next video. We have more problems to do. Maybe I'll do one more video on functions, and with that we'll stop. Okay? Have a nice day. Please subscribe to my channel and click the bell icon to get notifications. See you again. Have a lovely day. Bye.